HVAC 360 is brought to you today by the Cooling Tower Shower. Feeling grimy and disgusting at the end of a long day in the field? Well, grab your rubber ducky and your soap on the rope for our new shower accessory specifically designed for cooling towers. Simply extend and connect the piping, shut down that fan for safety, and let that anti-biological cooling tower water wash away your dirt. You can even turn the fan back on and use it as a big blow dryer. Never dirty the inside of your car again with the Cooling Tower Shower today. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, we're either sharing information and lesson learned from the field or talking with industry experts. But I don't stop there. I want to encourage you and everyone to come join the growing community of people just like you over at HVAC360.com and signing up for my newsletter. All right, so what's up for this week? This week, we're going to be talking with Jim Thornton, who is the National Technical Leader of Commissioning over at Henderson Building Solutions. Now, we're going to be talking about a hospital that's in the Mojave Desert. It's actually an Army hospital. So it was one of those things I saw at NetZero, and I just had to get Jim on here to talk about what's really involved in commissioning a NetZero hospital. You know, so I won't. It's probably about an hour long, so I'm not gonna belabor this too much. But just cut to the, or make sure that you stick around until the very end because there's some good nuggets there, right there at the end there. So, all right, without further ado, let's go cut to the tape with Jim Thornton. All right, today we're talking with Jim Thornton, who is the National Technical Leader of Commissioning for Henderson Building Solutions. How you doing today, Jim?
I'm doing fine, Matt. Yourself?
Good. Hey, we're going to have a conversation today about an article that you co-wrote that was in the ASHE, the American Society of Healthcare Engineers, their publication. So this was centered on over at Fort Irwin, which is in the Mojave Desert, the Weed Army Community Hospital, which is really more of a medical center from what you're explaining to me. So we're going to be talking about that, but first I think I give the audience a little bit of a taste to your commissioning background.
So I started doing commissioning full-time in early 2008, but I was doing commissioning in one form or another back in the early 90s during my time in hospital operations with Texas Children's Hospital. Testing, a lot of different types of testing, and found I had a knack for it. Anyway, I made a plan to go into commissioning that I made in 2000, 99, 2000. I went through a number of steps to create an entry point into doing commissioning full-time. I started in 2008 with a small firm in Houston. I did a lot of K-12, some GSA work. Didn't really do much healthcare, though I had done it previously. In 2012, I started working the New Orleans, their new University Medical Center. I spent not quite 3 years commissioning that hospital. That was 1.7 million square feet. I think the program budget on the hospital was 1.2 billion. That was kind of a project of a lifetime. And it was total building commissioning, much like the Fort Irwin Hospital is.
So now, the one thing that really caught my eye when I read this article was that obviously NetZero for a hospital. I mean, hospitals have been notorious for being just energy pigs as far as the usage of it. why, because, and for fair enough reason, because obviously the main goal of the hospital, its purpose is patient care. It's not necessarily, it doesn't care about saving energy for the most part. So when I saw this NetZero, I'm like, why NetZero for this project? What can you tell us about what you know about why they went after NetZero for Fort Irwin?
There's many reasons, and I don't want to try to second guess the Corps of Engineers on this, but at some point, the Fort Irwin Hospital became a project of primary importance for the Corps of Engineers because of its remote location, because of the base's primary importance to the U.S. Army as a training base for mobile warfare. They had in years past transferred their critical patients to hospitals, as much as 120 miles away via medevac, helicopter service, because the hospital on the base was not capable of handling trauma care to the extent that they had need for it. So from a NetZero perspective, they were wanting to apply their design excellence. What's the word I'm looking for? Their design excellence standards, not just to the patient care aspect of the design, but also to, as much as they could, to the energy efficiency aspect of the design. I think NetZero in part came about because of where the place is located at, the need for resiliency in its operations because of its remoteness, and the fact that it was an ideal location for a large photovoltaic solar array to provide the hospital with almost all of its energy needs. So it's kind of a combination of factors, if you will, that brought them there. I don't think that it was that they initially set out to do NetZero.
So, obviously with the NetZero that you're talking about, they have the advantage of being, in a desert, plenty of sun that goes around, and but even still, if you took out the array, this hospital probably performed pretty well, at least near NetZero kind of. I don't know did you know what the EUI? I mean, from some of the measurement and verification standards, where they were hitting as far as building energy usage?
They were targeting.
Yeah.
I don't recall the specific EUI that they were targeting. From a standpoint of the mechanical systems, the design really did not do anything terribly unique or unusual. What was done that reduced the mechanical loading were some of the more obvious things that you would do with the building envelope. The way the building was sited, the way that they did their shading of their fenestration, the use of a very reflective roof, the insulation, which they mention in the article, was quite a bit greater than the standard code requirement. They made note that it didn't make sense from a standpoint of life cycle cost as they are normally applied, but considering the age of the facility and its location, they felt like investing in additional insulation was worth the effort. So they significantly reduced the solar loading on the space, even though they have a fairly significant amount of glass, window to wall ratio, particularly in the atrium. But the way that they shaded it, the way that they sided the building to reduce the west exposure, all of those things kind of played into making the HVAC portion of the energy load of the facility smaller than it normally would be. So in estimating the percentage of demand that the mechanical systems placed on the electrical and other fuel usage, probably 25 to 30% is my estimate. Hospitals tend to be very plug load oriented. All the heavy equipment that they use in medical imaging, for instance, uses a considerable amount of power. And in decades past, that was just considered a cost of doing business. And as you may have noticed with ASHRAE 90.1, they've been addressing plug loads more and more as we get, farther down the road toward 2030.
I think I'm just going to interject here a little bit. I think just to give the audience understanding, this is not just a small building that they made NetZero. This is actually a fully functional hospital. I mean, it really compares to anything that you'd see out there in any of these standard community hospitals. They have all the imaging suites. They have everything from soup to nuts to take care of the soldiers out there. Correct?
That's correct. So this is this hospital, if I understood correctly, is a trauma 1 center, meaning that it's capable of handling any type of traumatic injury that can come through their doors. Being that they are a training facility, and moreover a training facility that uses live fire, including cannon, people get hurt, and sometimes really badly, and they needed something there to increase the survivability of their patients. What they had before wasn't enough. So this hospital they've done really two things. This is a hospital, but it is also a very nice clinical care facility for the base. So it's more of a medical center rather than just a hospital. The hospital itself takes up about a third of the campus. The clinical care facilities take up the balance, excepting the cup.
Now, how does your mindset when you think about I've never commissioned a NetZero building. What sort of things go through your mind when you think of a NetZero building? Like, hey, I'm going to have to get more information on this, or what? I'm specifically have to find more information about these systems. So, what is your kind of process about the mindset of NetZero?
This is the second facility that I've done that was NetZero design. The first one was Golden One Center in Sacramento, which ran kind of concurrently with this one, but completed before this one did. The main thing about NetZero from a commissioning standpoint is, are the assumptions in the energy model reasonably accurate? In other words, are we looking at something that has pie in the sky assumptions about how the building's going to do, or does it really reflect how a normal building will be used? So that was in our mind to a degree. From a standpoint of the commissioning perspective, we wanted to get a sense of how they approach the energy model. This project has measurement and verification on it. In fact, we're still doing, or the folks that I was working with at AECOM are doing measurement and verification work still on the facility. There is sub-metering of the facility to allow kind of a focus approach on where the energy usage is occurring, and trying to break out the different pieces to determine, where we're using the energy. Is it within the norms that were identified in the energy model? And if not, why not?
Now, you you mentioned the energy model. I got to ask, was this something that was done in-house by the engineers, or did they have a third-party consultant doing this?
They had a third-party consultant. I'm afraid I don't remember the consultant's name, and I really kind of feel bad about that. But when we looked at the energy model against the measurement and verification aspects, we wanted to do a calibrated model to comply with the measurement and verification option that was chosen. And one of the things that we ran into was a reluctance by the third-party consultant to provide information related to their assumptions, which made things difficult to develop a calibrated model. But the group is still involved in developing that model and has found a means to work around that limitation.
Right. So, I mean, obviously, if people aren't familiar with calibrated models, you have the basic assumption of the design. So you know what the usage is going to be, when people are going to be there, the occupancy. I understand the typical loads and loading, but that doesn't necessarily have to match with reality. So it's important to calibrate the model, or make sure and verify all these assumptions. So that's where you're wanting that information from the energy modeling consultant, but you're not getting it.
No, we asked for a copy of the model. Energy models are developed through the use of different software, and AECOM retains the ability to use and the skill sets to use most of them. So the consultant that provided the model would not provide us with a copy of the model. So we had to build a model from scratch using the contract documents.
Right.
And we're using data from the electrical sub-metering, the gas metering. We're using data from the building automation system from a standpoint of temperatures and the operational aspects of the chilled water and hot water plant, the scheduling aspects of the clinical, the clinical space. The hospital itself is a 24/7 operation, but the clinical space, they keep more normal business hours. So the purpose of going through the measurement and verification is to confirm that, hey, is this thing doing net zero energy, or is it not? So we're looking at the production of the photovoltaic array. It feeds into the power monitoring control system, along with the energy demand side of it. And it's kind of a challenge going through it to the extent that we've gone through it thus far, and we'll continue to go through it the remainder of this year.
So do you have any sense on whether or not it's going well, or it might be a little bit off?
They have had problems with some aspects of their operation, primarily related to water quality, that have affected the mechanical operation of the facility. They addressed them as they've come up, but there were certain assumptions that were made late in the design period that took the reverse osmosis system that they had designed for the facility out of the design because of a concurrent water treatment project at the base's water treatment center. So concurrent to the hospital project, the base upgraded their potable water system. And the expectation was that the water coming from the potable water system would essentially do away with the need for most of the reverse osmosis. So they deleted it from the scope, even though it was originally in the design. What we found when the building started operating is that the potable water treatment plant was not hitting their conductivity targets, and so the hardness of the water was more of an issue. This created issues for both the mechanical system as far as the condenser water treatment. It also affected the humidification. They have spot steam humidifiers that serve the humidifiers for the various air handling units and some of the zones that serve the operating rooms. So they've gone back in and they've added some additional reverse osmosis capacity to the facility, but it had an effect in how the facility was operating on the mechanical side, and so their energy density ended up being a little higher than what they expected it to be for the first year.
So I know that in taking a look at the article, just kind of briefly, I know you weren't involved in the design, but as far as the article states, they said the design was completed in 40% of the usual time, which was one of the things that stood out to me when I was reading through it. And I know that the one thing a reader should know is that the AE firm RLF has done a bit of work with the DoD before, so they kind of know exactly what they want. So shaving off 40% of the design time may not be as dramatic as they kind of originally stated. And another thing you had mentioned that we're not looking at really creative MEP systems. They're pretty much standard. The article lists what you have there. You're just basically condensing boilers and maybe a low condenser, a low water return temperature. But it's
correct.
Pretty much just standard. And you'd pointed out the melting envelope, which is really the the highlight of what makes the energy reduction possible for this facility.
From the standpoint of the solar loading, that's correct. Yeah. So what the audience needs to remember is that a couple of things. This is a base that is very remote from the nearest urban area, which is LA. They're about 2 hours from Ontario. Anybody knows where that's at?
Ontario, California. I'll just state that.
That's correct. Ontario, California. They're about 3 hours from Las Vegas. So being able to staff a hospital with qualified operations staff in a location like that, and working in the desert, it's challenging. So they chose to go with systems that weren't particularly challenging from an operational standpoint. The the capacity of the local trade community to provide qualified staff for a facility that is using chilled water and gas-fired hot water systems, both domestic and heating hot water, was of more importance than was using something unique that might have issues with reliability. So they chose to, I guess, get themselves to the NetZero by approaching it from a standpoint of the production side, using photovoltaic energy for the electrical demands. The photovoltaic system on site is, I believe, a 2.2 or 2.4 megawatt facility. And then the domestic hot water system is using a vacuum tube solar domestic hot water system, which is mounted on the roof. And it provides roughly, including the storage, it provides about 3 days of heating. So even if they go through an extended period of cloudy weather, the domestic hot water storage gives them about 3 days before they have to start firing the domestic hot water boilers. That said, the domestic hot water solar system is backed up by a propane-fired domestic hot water boiler system. So I guess what I'm saying is that the Army took the approach that they needed a facility that they could maintain, but they wanted to make it as independent from outside utility requirements as they could. Some of this had to do with the desire to hit net zero, but some of it also had to do with resiliency. Can this facility operate without a connection to the utility for an extended period of time, due to a natural disaster like a massive earthquake or some type of man-made disaster? And I think they succeeded. It was a balancing act from a standpoint of the design between trying to achieve something unique and achieving something that was operationally maintainable.
So now you yourself doing the commissioning, it states in the article that there is a 6 to 7 month functional testing period. Can you describe for people what's involved in a functional testing period for that amount of time?
Because we were dealing with a total building commissioning approach, in the way that the project stages, how it comes together, how it's constructed, how the work sequences, the functional testing period is probably a little longer than what you would find with a typical lead commissioning project, even one of any real size. So in this instance, we started testing different aspects of the electrical system, actually back in the fourth quarter of 2016, with the NETA testing agency coming out and testing the electrical switchgear. We moved into the testing of the diesel generator plant, which was, I think, I'm trying to remember, 4.5 megawatts, I think, total. And a megawatt and a half of that was redundant. So the generator plant was tested several times over that 6-month period. Some of it was the testing of the generators themselves. Some of it was the testing of the paralleling gear. We did 3 tests of the emergency power system from a standpoint of validating all of the control sequences in the SCADA control package through all the different failure scenarios. And we did it that way to basically to confirm that we had achieved repeatability of function. So that aspect of the functional testing period alone stretched the testing period out probably 2 or 3 months beyond what it would normally be should it be like a lead version 3 project where you're dealing with mechanical and lighting controls and some plumbing. So the electrical testing was somewhat unique, was very extensive. We did do, as it mentions in the article, an integrated systems test that involved disconnecting the site electrical utility from the site and seeing the system, all the different systems come up and respond. And we did find some problems, you know. There were a number of building automation system microprocessors that did not have UPS power to them. And when they went offline because they weren't powered up until the emergency power system came up. It took probably a greater period of time for the building automation system to restore itself than it should have. So that's one of the things that was identified that they needed to address. We also found some issues with the fire alarm system that we addressed during that time. So from a standpoint of the mechanical systems testing, that was more straightforward. We started at component level. We did system level testing, both air side and water side. And then we did interoperability testing, you know, particularly between the electrical systems, mechanical systems, as far as how they responded when the normal power came off, but also the fire alarm and the security systems, how they responded when there were power outages as well as in normal conditions. Security systems in particular, because of the nature of the facility, went through extensive testing, you know, because there were part of the security system limited egress deliberately. The infra protection system, for instance, is designed to limit egress so that somebody cannot leave the hospital, you know, kidnapping a baby. But there has to be a means to get out of the hospital if your fire alarm system goes off, and there's a method to test the security system to confirm that all paths of egress, you know, open when the fire alarm system in a given zone went off.
So now, obviously, one thing I want to point out to people is if you don't understand, you made a kind of a good point, and something that happens a lot, especially with the building automation system and emergency power. Emergency power is something that it's not instantaneous. So there is kind of a blip in the, you know, power supply. And anything that has, you know, a microprocessor with, you know, like a computer in it, doesn't handle blips well. And that's why you kind of want to have them on UPS systems, even if it's a small local UPS, just to be able to handle that blip so they don't go down and have to reboot. Because like you mentioned, 100 things can, you know, 100 different things could go wrong when something has to actually reboot as opposed to just, you know, maintaining power.
That's correct. So actually, I like to see a complete disconnect of power for at least a minute from a standpoint of building automation system, because it allows the capacitors within the microprocessor to power down and to restart, you know, in a more ideal condition. When you don't have that, particularly when you are dealing with a microsecond blip, which this hospital does experience, you know, the electrical utility provided this hospital is roughly 40 miles away from the point where it comes off of the primary high power distribution. It's one feed coming into the base, and then it splits and feeds multiple substations. The hospital is fed by two different substations, but coming into the base itself, there's one feed. And because of the distance and the climatic conditions, electrical blips are not uncommon. And what I call microsecond blips, where you lose power really very momentarily, less than a second, sometimes maybe 2 or 3 seconds. And then it reestablishes itself. It's not long enough to bring on the emergency power system, but it is long enough to create havoc with your microprocessors. And so when you have a condition where you have not really done anything to establish power security, from a standpoint of your utility, you really need to look at the low voltage systems that you're relying on and determine what parts of them need to be circuited through some type of UPS system, uninterruptible power. Because what can happen is you can go offline momentarily, the thing come back up, and it scrambles the code that the microprocessor is operating under in the resident memory. And the only way to correct it is to cycle the power and let the capacitors bleed down before you start back. To get a clean start. And you can see some rather strange things with the microprocessors when it goes through a really momentary type blip. Some of the operations people that may be listening to this have seen this kind of thing occur probably more than people that are on the construction side of the business.
Absolutely. So now, over the course of the commissioning, what was some of the other things that you found that were wrong that might have been included in, say, a lessons learned type of format?
Yeah. So one of the things that was really took some time to resolve had to do with the fuel system supporting the emergency power generators. The fuel system used a combination of underground tanks and day tanks that were mounted separately from the generators, but in the generator room. The day tanks held roughly 500 gallons and were really intermediate storage. So as the day tank would draw down, the pumps on the main tanks would start, fill the day tank, oscillate, back and forth, depending on how long the generator would run. I've commissioned a few of these. Normally, I see a small pump, a fuel pump, between the day tank and the generator to provide a positive head going into the generator's fuel system. In this case, they were relying on the suction capacity of the generator's fuel pump to draw fuel from the day tank. The way that the day tank was configured, the pickup tube was placed in the tank in a location that created a venturi in the tank. It's just the geometry of it. So what was happening is we would get this venturi created that was drawing air into the pickup tube, and we would lose our prime. So that was a really unique problem. I've never dealt with something like that in the past, at least in that kind of that kind of situation. And it took us several weeks between the engineers and the people working at the site. I had involvement in testing different aspects of the piping system to determine if we had suction side leakage in the piping, which is kind of an unusual thing to test for. Normally, when you're testing fuel oil piping, you test under positive pressure. But because this system was relying on negative suction pressure between the day tank and the generator, we had to test under a vacuum state to determine if the piping actually was airtight in a negative condition.
Yeah, if people aren't understanding the Venturi effect, is that you can imagine it's kind of sounding like a bathtub drain. So you have the water swirling, and you have the air kind of in the middle of it. And what ends up happening is when you're drawing from a condition like that, you can actually get the air all the way into it. Just kind of siphons all the way into the intake, and obviously, you're adding air into the system, which is not what you want.
No, it'll knock generators right offline. So just to be clear, these day tanks are vented. So, they weren't pressurized. And we ended up finding a location to mount the pickup tube, and we extended the length of the pickup tube so that we were about a half an inch roughly off the bottom of the tank. And between the location of the pickup tube from a geometry consideration and the distance of the pickup tube from the bottom of the tank, we were able to disrupt the Venturi to the point where we were able to draw a solid column of fluid. And we didn't have to go in and add a pumping system, which was a good thing. And they've not had any issues with this fuel oil system related to the fuel pickup since they occupied, I guess, in September of 17, I think it was. So anyway, that was probably the most unique of the issues that we found. One of the more troublesome issues, because it was unexpected by everybody, including the manufacturer of the day tank. What else did we see that was unusual out there? The domestic hot water system used vacuum tube collectors, and these things are made out of glass. The tube that the water flows through is copper, but there is a glass tube that surrounds it that is held under a vacuum, and there's not any kind of separate vacuum system to maintain that vacuum. It's basically hermetic. So what we found was, because of the extreme temperature changes that the system would see, in any given day during the summer, it goes from about, I think overnight, they get down into the low 80s, and then it gets up to 115, 120 degrees. So there's a fair amount of expansion and contraction that takes place over a given day during the summer on this system. And what we found was that if the geometry of the tubes in their placement in the manifolds was not exactly as it needed to be, it would crack the tube and they would lose the vacuum. And it was very obvious when it happened. So it's become something that they have to keep an eye on probably more often than I think they had planned. So periodically they do have to change tubes.
Is that something that's, I mean, to me, it doesn't seem like that's something that's very easy to do. Is it?
It's fairly straightforward to change the tubes out.
Okay.
But the concern that I had with it is, with all the focus on the resiliency in the building design, the mechanical system design, the electrical system design, I just found the use of vacuum tube technology to be unique, in that it's knowing, what we know about vacuum systems in general, how difficult it is to maintain a vacuum. I think if I was to suggest to a design team an alternate means of doing domestic hot water production, I would suggest something other than a vacuum tube system. There's thermosiphon, there are open loop systems, there's closed loop systems that tend to be more robust in design. And the difference is the vacuum tube system provided them with a higher level of thermal transfer efficiency. And that's, I think, part of the reason why they went with it. But from a standpoint of resiliency, I probably would have selected something a little bit more robust.
Right, because even though you can have these tubes, I'm guessing on just a stock item, to be able to get more, it probably would be a lengthy process. You're probably looking at a couple of weeks.
In this particular instance, the manufacturer was based in England, and I don't know if many of the listeners have dealt with getting parts from Europe, but you're not talking about something that you overnight. You're usually talking several weeks in production, and then of course transit, usually by ship. So they have to have an inventory on site, and when it drops to a certain level, they have to buy some more. The other thing that concerns me about a system like this is the company that manufactured this system, relatively speaking, is fairly small. And if at some point, they either get bought up or they go out of business or they have some kind of planned obsolescence for their collectors, at what point are you going to find yourself with a system you can't use? But still within the lifetime or the life cycle of that system, because you can't get vacuum tubes. So I like the system from a standpoint of its technology, because it was very thermally efficient. But from a perspective of resiliency and from a perspective of reliable service long term through the expected life cycle of that plant, I didn't care for it.
So now, obviously, we talk about a little bit about the maintenance staff, and when you go through a training for a NetZero facility, what sort of special considerations do you have to have when going through that process?
So, I try to make it a practice that all the training is video taped. That a videographer is present, has set up the equipment. He's using special equipment when he's testing, or rather when there's training going on in front of loud equipment, so that the audio is not just overwhelmed by the mechanical noise. From a standpoint of a new NetZero facility, there has to be more of a focus on the sub-metering aspect of it, and making sure that your power monitoring control system is working correctly, that your building automation system is trending correctly. So there's training aspects related to using those systems, from an operations standpoint, that are probably a little bit more unique than the typical training sessions that you find on a hospital facility. The need for an inventory, a local inventory, because of the facility's remoteness, rather than, ordering something when it fails, something that is a consumable, right? Belts, filters, what have you. Talking about those during training, making sure that they understand that they need to maintain an inventory, they need to provide space for it, and they need to do it in a way that it's not going to compromise the fire alarm system or the fire egress system. Those are all considerations related to the training. One thing that I do want to mention, and this is a problem that I find in almost every commissioning project that I've ever worked, is that most of the people that are going to be operating the building are fully employed and are, if not fully utilized in their current activities, nearly so. So it's very difficult to find a way to get the people into the classes and, being able to sit through. The training on this facility went for weeks, all the different training that they did. It wasn't just the MEP systems that they had to train on. They had other things that they had to maintain in the facility. So training went on for weeks and weeks. And frankly, I don't know how you do that with a training organization that has people that are already committed full time to other jobs. In this case, people that were working at the existing base hospital, they had work to do to keep that hospital running, and they also had work in other locations on the base. So it was difficult to get them there on every training session. Sometimes they made them, and sometimes they didn't. So be certain to provide a means to properly, I'm going to use an old term, videotape your training session. Preferably use the services of a videographer, because you're going to need those recordings. These guys are going to have to go through training sessions that they missed. They're going to have to go through training sessions that they've been through before, but unless you're using that information on a daily basis, you're going to lose that information. So having the ability to have a structured training program that basically goes through, some retraining aspects of the staff should be part of any new facility. How are you going to continue training your staff? How are you going to deal with the turnover that is inevitable as people move through their careers? You need a means to continue the training of your staff so that they know how the building is supposed to operate. There is some institutional memory, if you will. The alternative is that you have staff changes that don't go through the training they need. They operate the building the way they think it's supposed to be operated, and quite often it's not operated correctly. And you have failures that are unexpected and very unpleasant to deal with.
Absolutely. I think one thing that I'll add in there with the training, you said independent third-party videographer. I would ask at least for some sample of training they've done before,
Yes.
Because dealing with a loud environment is completely different than just shooting any sort of video. So
That's correct.
if they've done other training sessions before, get a sample and make sure that the audio quality is up to snuff.
That's correct. It is one of the things that I have dealt with in the past when a videographer was not specified, and we relied on the construction manager to provide the video recording. They'd set up a camcorder like you'd use to take your family to Disneyland, with an omnidirectional mic mounted on the camcorder. The trainer is standing next to the equipment. The camera is probably 12 to 14 feet away, and all you hear is the noise. What good is that? So I realize that it's an expense that a lot of people really don't want to make. They've got other things that they're committing their resources to, their financial resources to. But you're going to live with that building for 50 years. If you're living with a building for 50 years and you want it to be reliable in operation, your operation staff has to be trained properly, and there has to be a means to do retraining. And if you're going cheap on the use of the recording of your training sessions by using a little Sony cam, you're going to pay for that over and over, and not in a way that you want to.
Right. For anybody in that particular case, if it's relied on the CM or the GC or whoever's doing the recording, to them it's a checkbox. They don't care about the quality of the output. It's just that it's been done, and it's
right.
They've fulfilled their contractual obligations.
Yeah.
Simply put. Hey, I want to wrap this up here, Jim. And so, any final thoughts as far as commissioning a NetZero hospital? I mean, what do you want to leave people with?
If I was to go back and do this one again, I would focus a great deal more on system integration during design phase, particularly the coordination between specifications of the systems that have to integrate with one another. I would spend a great deal more time and effort in that aspect of it. There are multiple systems in this hospital that rely on one another, and we had to work through issues related to their integration that probably would have been worked through a lot easier had they been addressed in design phase. So this is a wonderful hospital. It has a great deal of wonderful features to it. And it's going to provide the fort with, great medical care for decades. But things would have gone, I think, easier, and the operational aspects of the facility would have been easier to complete had there been more of an effort placed in properly defining the integration requirements of the different systems that have interoperability needs.
All right. Well, that's absolutely great. Jim, I appreciate your time and talking with us. And, if anybody wants to read the article, I will link that up in the show notes. So it's the Health Facility Management Magazine, and I'll definitely do that. So I appreciate it, Jim. Thanks for coming on.
Thanks for having me.
All right. Thanks again to Jim Thornton for taking the time to chat with us. Check out the show notes for the link to the article and some of the other things that we mentioned in the interview. So you can find the show notes over at hvac360.com/136 for episode 136. All right. That's it for this week. Thanks so much for listening. Hope this was helpful. As if you know somebody who's looking to get more education on this, or is interested in NetZero, interested in hospitals, interested in commissioning, why don't you go ahead and share this episode with them? That's one of the things that you can do to help the show out. Two other things that you can do is go and subscribe if you haven't already over at hvac360.com. I'd be greatly honored if you'd go over to Apple Podcasts and leave me a rating and review there. And lastly, we are also putting the show on YouTube. So if you go, even if you listen to this on your podcast player and don't listen to it on YouTube, go ahead and subscribe over there. That's going to allow me to reach more people and to do some fun things in the future if I get enough subscribers there. All right, that's it. That's a wrap for this week of this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.